Hello, my name is Philip, and this is my third lab report. For this lab, the purpose of this was to predict the behavior of circuits with resistors in series and parallel, utilize multimeter to measure values of conventional current and potential differences in the circuit, and examine behavior of ohmic resistors and capacitors. There are two parts of this experiment. For part one, we got the current to be 0.0195 amps and the potential difference across resistors to be 0.75 volts and 1.72 volts. The change in the voltage and the voltage drops are shown in the graph. For part two, we used two different light bulbs with two different resistances. We got RC for the first one to be 33 and the second one to be 8.33. As you can see, the higher resistance meant that the light bulb lasted for a longer time. Fundamental principles uses this lab was the node rule, loop rule, and the voltage relationship with circuit elements. First one states that current flowing into a node must be equal to the current flowing out of it. Second one states that the sum of all electrical potential differences around the loop is zero, and V equals IR and V equals Q over C. These two can be used to find the voltage for a resistor and a capacitor. For the first part of the system is a circuit made by two resistors, 47 ohms and 100 ohms, two ammeters, and two batteries. These are all connected in circuit, which means that the total resistance is the sum of the resistance of the resistors, which is 147 ohms, and the current is equivalent at any point of a series circuit. Using these information, we get the current to be 0.0204 amps. The steps for this is that we first measure the current of the circuit, reverse the ammeter connection and remeasure, and then we read the ammeter and voltmeter readings. And finally, we find the voltage drop across circuit components, and the sum of voltage drops here should equal the voltage of the battery. For the second part, we connect the battery, capacitor, and bulb in series, record the time until bulb dims, disconnect the battery and connect only the capacitor and the bulb, record time until bulb dims, and repeat 1 and 2 for a bulb with different resistance. Here, the RC value should be the resistance times the capacitance, and this tells us how long a light bulb will dim, or in other words, how long it will take for a capacitor to fill up or discharge. For our first experiment, the battery was actually lower than what we expected, so it was 2.87 volts. And because of this, we had to change our expected current, which is about 0.0195 amps. As you can see in the picture, we got 0.0193 in the first one and 0.0197 in the second one. So the obtained average current turned out to be the exact same as expected current. So for the ammeter, we got the reading as shown, but when we flipped it, we got a negative number because the ammeter has a current reads the current flowing in one direction. So if we flip it, we get a negative current. The voltage readings for the 47 ohm resistance was as shown, and the resistances are not present in the wire or the ammeter, and they're only present in the resistors. And the sum of the voltage was 2.87 volts, which matched what we expected. So the ammeter reading after connecting the voltmeter across the 100 ohm resistor went slightly down because voltmeters have noticeable resistance compared to the wired ammeter. This is why the ammeter didn't affect the current at all because it has such a low resistance. As you can see in the graph, where the ammeter is very flat, but where the resistors are, there's a decrease. So they because of the first law as the second law where the conservation of energy exists, the initial voltage and the final voltage is both zero. For our second experiment, a higher resistance extends the time of the light bulb as seen, and this makes sense because higher resistances increase the RC value. So for both charging and discharging, light bulbs start bright and dims until the light is no longer visible. Some sources of error in this experiment is that the ammeter was off a bit. The two ammeters showed different numbers, and equipment like the battery or the resistors were slightly worn out, and this could have led to a different result. Also, for the second experiment, the timing for measuring the time it took for dimming and was not accurate. And if this was done on a simulator, time could have been exactly measured when the light bulb dimmed. The resistance of the wires are zero, and there should be no errors from manufacturing process and wear because it's on a simulator. Thank you for watching.